Hello, everyone. I'm Nagappan. Like Samer said a few minutes earlier, I started along with Samer a year ago. So I've taught this course once. Actually, I've taught this course a few times because I was a professor somewhere else as well. But yeah, so this is CS 846, Empirical Software Engineering using ultra-large repositories. I am an empirical software engineer. I've been doing that for about 12 years now. The class is on Wednesdays from 1 to 3:50, so it's about 3 hours once a week. Just to give you, what empirical means, right? Like Ernest Rutherford kind of said that, the only real science is physics. Everything else is, just stamp collecting. But he himself got a Nobel Prize only in chemistry, not in physics. But what we're doing is like stamp collecting, but it's a little bit more interesting, I think. It's more like Darwin's work, right? Like Darwin had a theory about evolution, but he kind of went to Galapagos and he saw the finches and he categorized the finches. He observed how the beaks were different. And based on that, he was able to say, hey, this is the most likely theory of how we are who we are, right? So that's what we're going to do, but we're going to do that with software. We're going to go to an island like GitHub, and then we're going to look at many different types of software that does one type of thing. Like we don't want to study one game and the Linux kernel and try to see what is common between them, right? I'm sure Angry Birds is not developed the same way that the Linux kernel is, right? And we don't want to include both of them in the same category. But we want to look at a collection of software, and we want to observe how the developers are building that software, make some hypothesis about, or come up with some hypothesis about how software should have been developed, look at the data that is available, and try to see if our hypothesis is true or not. So unlike certain kinds of research that you might have seen where you're trying to improve something, the kind of research that we're going to look at in this class is we're not building something that's better. We're not trying to improve the performance. We're not trying to, get the memory consumption lower or the time of execution lower or anything like that. What we're doing is we're observing. So there's no right answer or wrong answer. There's only an observation, right? We observe what people are doing, and we report that. That's what this course is going to be about. So we would consider, all the open source projects that are there. GitHub has about 20 million, but about 6 million we can actually have access to. And there are different repositories with different kinds of information. But it's not only about the code, right? I don't want you to think that we're only going to look at source code in different open source repositories. There's also all the apps that are available in the Google Play Store, which can be mined. We can look at the binaries of those. We can look at the descriptions for those. We can look at what reviews are coming, how people are responding to those reviews. There are some apps where user reviews are taken seriously by the developers and they make changes. But it is done at different frequencies, right? There are some apps which are released, which are updated every 2 weeks. And so they are looking at what reviews come in only in the last 2 weeks. They don't care about what happened a year ago because that's too old, right? We also look at execution logs from systems and try to find out what parts of the system are being used more often by the users, and how we can help the developers kind of prioritize their limited resources. We can look at the Stack Overflow. So Stack Overflow actually allows you to download the whole Stack Overflow data as a MySQL table, and then you can just query all of it, right? So we want to see what kind of questions are people asking, what kind of questions are getting answered, what kind of questions are not getting answered. How can we reduce the time to, for an answer, right? Things like that. We want to observe things like that. So the twist in this course is we're going to look at ultra-large repositories. So far, in the last 20 years or so in empirical software engineering, due to the lack of data, a lot of studies have been done on a few software projects. But now, we have access to a lot of data that's available quite easily. Yes, you have to build crawlers for this to get the data, but it is available, right? And we've partnered in this course with Microsoft Azure. So all the students would get accounts on Azure and credits on Azure to crawl the data, do analysis over the data. So you have the computing resources as well, right? And that's the second point, is that we have the computing power now to crunch through this data. You know, like the Android apps, if you download 100,000 Android apps, then that's about 300 or 400 gigabytes of binary alone. You have the space to store it, you have the compute power to analyze it, and when I mean you have, I'm saying that you actually have credits in Azure to do it. So the class structure, as I said before, is going to be once a week, about 3 hours. A few lectures in the beginning on applied statistics, mostly because you will be using a lot of that later. It's certainly not going to, you should not be taking the course to learn the statistics. You should be taking the course to learn about software engineering, but I don't assume prior knowledge in statistics. So about the first lecture will mostly be about applied statistics. Again, not how the things work, but how to use the different classifiers and how to build a regression model and things like that. It'll be seminar style following. Every week we'll have a certain topic and there'll be 2 or 3 papers. Everybody will be expected to read all the papers and write a summary for those papers. One of the students will present, and you know, some of us will be adversarial to the paper, including me, and I'll pointedly ask questions to get you to think about things, right? And there'll be a course project, which there'll be presentations for those as well. So these are some of the themes that we'll cover in class. We'll talk about papers where they've discussed how to collect large data sets. And there are some issues with that, right? If you try to go and download 100,000 apps from the Google Play Store in one go, Google will block you, right? And so it'll also block anyone in Waterloo from ever downloading an app. And we don't want that, right? So we have to be careful about how we go about doing this. We'll talk about some research done on the App Store. We'll talk about reverse engineering, log files, debugging, and mining some unstructured data like the questions on Stack Overflow. The evaluation will be based on the presentations and the discussions that you have, class participation. I'm going to keep track of who's talking, who's asking questions, who's answering questions, and like a token-based system or something, and actually be more specific on how the grades for that shake out. But the course project, typically in the last 4 or 5 times in different places where I've offered, I've had students do a new research project. But I've also realized that those courses I've always taught to PhD students or senior master students and not incoming graduate students. So while you have the option to do something, a new project, I am expecting everyone to do a replication project. So you take one of the papers that are there that we discuss in class, and you have to replicate it on the data set that the original authors have, and scale it up to a new data set that you will collect and evaluate how the results change. So that is what will be expected from each student. So you will not have to worry about what research question you're going to ask, but you will look into how to solve that research question. So I want you to go through the whole, all the steps in doing a research project. So these are some of the past student projects that have been done with me in my course, which have been published. So if you do something and the results are great and you do a good job at it, there is a chance to publish those things. And so these are some of the papers that have been published from the class. And we even built an infrastructure for other software engineering researchers to use as part of my course previously. That's it. So thank you.